Warm greetings to all. In this unit, we are going to see information theory and channel capacity. First of all, we can come across the topic of measure of information. Information is a measure of uncertainty. It will be indicates the probability of occurrence of certain messages. If higher is the information, the probability of occurrence will be less. Since the information has been closely associated with the uncertainty, so which can be defined by the equation as the information is equal to Ik, that is which is equal to log of 1 by Pk. So which will be related to your information to the probability of occurrence as inversely proportional, which can be given by the equation as minus of log of Pk. So Pk will be indicates the probability of occurrence of symbol K, and Ik is the information carried by the symbol K. Next one, we can come across what is entropy. Entropy is defined as a term in terms of probabilistic behaviorance of a source of information. So we are going to define the source, output, or discrete random variables, which will be having a certain finite alphabet with certain probabilities. So for all the probability of for each and every messages, which will be having some probabilities. So we are going to define a set of information symbols. So we are going to find the average information content for the given source symbol. So that is, we can say it as entropy is the average of information. It can be defined by the unit as bits per messages here. So which can be defined by the equation as h of k, which is equivalent to the cumulative of the summation of the values here of the symbols. So which can be defined as k is equal to 0 to k minus 1, pk log base 2 of 1 by pk. So the next one is a problem which can be based on the entropy here. So find the entropy of the source alphabets S0, S1, S2 with respective probabilities, which has been given as P0 is equal to 1 by 4, P1 is equal to 1 by 4, and P2 is equal to 1 by 2. So further entropy, as we know the formula for entropy as a summation of k is equal to 0 to k minus 1, pk log base 2 of 1 by pk here. So based on the probability which is given here 1 by 4, 1 by 4, 1 by 2. So in this problem, h of k is equal to summation of k is equal to k minus 1 pk log base 2 of 1 by pk. So based on the probability of occurrence of 1 by 4, 1 by 4, 1 by 2, by substituting those values here, so we'll be getting the probability as 3 by 2 bits here. The next topic is rate of information. If a source generates at the rate of r messages per second, the rate of information capital R is defined as the average number of bits of information per second. So H is the average number of bits of information. You can find the rate of information as R is equal to R into H. That is, can be expressed in the unit of bits per second. So the next topic is source coding. Source coding means it is called as lossless data compression technique. Means that it will be removing the relevant information from the signal before transmission. So there are different types of source coding schemes are available. So one is half-band coding, second one is Shannon-Fano coding, and third one is Lempel-Ziv coding and prefix coding. Among those different coding schemes, half-band and Shannon-Fano coding has been included in your syllabus point of view. So we are going to be discussed mainly only on the topic of half-band and Shannon. So what is the need of source coding? For analog sources, the source coding is related to the amplitude distribution and the function of source waveform. For discrete sources, the source coding is related to the information content and the correlation among the symbols of the source. So this is the reason we are going for. And this is after doing this encoding the satisfied functional requirements, it should be having the efficient representation of the data in binary form. It must be uniquely decodable. So the first one in source coding theorem, the output of any information source having the entropy h per units per symbol and encoded with the alphabet of n symbols will be represented as a average length not less than n slash log n. So the source coding theorem states that encoding of messages from a source with entropy can be done bounded by the fundamental information which can be given by the equation as h divided by log n. So which can be given as a minimum average number of symbols per message. So from that the average code length can be determined here, which is a probability of pk and ik. Next, L represents the average number of bits per symbol. The code efficiency is which is equivalent to L minimum divided by N here. So from that, the average code length for any distortionless source coding scheme can be bounded as L greater than or equal to H of S here. So the efficiency can be determined by H divided by L here. So that we are going to be in source coding, we are going to come across what is half-band coding method, which can be represented here. So in half-band coding method, the binary case that is at least the last two probable source output symbols are joined together and resulting in a new message alphabet with one less symbols. So this is you can call it as half-band coding. So it is a uniquely decodable code and it is the smallest. It has the smallest average code word length. What is the main disadvantages means? It has large tables which give complexity. It is also sensitive to channel errors. This is the procedure for your half-band coding. So we have to create a list of symbols. We should be represented in the form of decreasing order, and the probability with the last two symbols should be assigned as zeros and one. Then we have to choose the last two symbols or combined together to form a new symbol with the probability equal to the sum of the individual probabilities here. This procedure will be repeated until we are left with two symbols only for which zeros and ones are assigned. So, half-band code is a bit sequence obtained by working backwards and tracking the sequence of zeros and ones, which is assigned to that symbol and its successors. So, let's see one problem for the half-band coding. So, they have given the that is totally yes, not to identify so symbol alphabets, so which is having the probability of 0.1, 0.2, zero point 0.4, zero point 0.2, zero point 0.1. So here we are going to proceed towards the next stage here. So that we have to take the last two probabilities which is going to be added. From that it has been given to the, as we have taken the last two probability here. In this problem we have 0 0.4, 0 0.2, 0 0.2, 0.1, 0.1. So we have to choose the last two probabilities which is added and we are getting the probability as 0.2 here. And next we are going to pick the zero point 0.2 as downwards, 0.2 as downwards here. Now we have the four probabilities. Now we have to choose the last two probability as 0 0.2 and 0 0.2 as zeros and ones. So this, after adding this, we'll be getting the answer as 0 0.4. That can be proceeded towards the next stage. So next from the second stage, 0 0.4 has been proceeded towards the stage 3 here as 0 0.4, and 0 0.2 will be moving towards the next stage as 0 0.2 downwards here. So likewise, we have to continue the same procedure until we are getting the total probability as 1. So this procedure has been repeated and we are getting the probability as 0 0.6 and 0 0.4. So we should be having the total probability as 1 here. Now we have to find the code word. So likewise, we have to mention the probabilities as zeros and ones in the last two digits. So now we have to find the code word as the tracking from the right to the left side here. For 0 0.6 as zeros and 1. So as 0 0.6 has been moving towards here 0 0.2 here, so we'll be getting as 0, 0. Next one for second alphabet will be having as 1, 0. For third alphabet is 1, 1. And fourth alphabet is 0, 1, 0. And the last one will be having a 0, 1, 1. So from that, we should be finding by using the code average code learn. So which is given by here. So we have to multiply the probability with your code word. Code word length. So how many code words will be in length? We have find it out 2, 2, 2, 3 and 3. So likewise we have to mention the code word length, we have to multiply and get the answer as 2.2 here. After doing all those process, you have to go for entropy calculation. For entropy calculation, as we have studied in the previous section, what is the formula for pk log base 2 of 1 by pk here? So you have to substitute those values here. 0.4 log base 2 of 1 by 0.4 as we continue for the 5 alphabets. After substitution of those values, we are getting the entropy as 2.12.